Okay, the final way that we can find different volumes using integration is by finding the volume of a cylindrical shell. And these can be just a little bit tricky because it requires your brain to think a little bit differently than we would normally think. So I'm going to show you this, and it's just going to take some practice to get comfortable with the shell method, okay? And a lot of times, instead of using a shell method, you could use a washer method. But sometimes it's easier to use the shell method as well. So I'm going to show you how to attack this guy, and then you can practice it on your own. And just like with some of the previous slides on this, with my kids, you've shown me how to do integration already. So you can use your calculator. With other kids that are watching this, and your teachers may be not quite as strict, or if you're in an AP calculus class, you'll need to work this out by hand. Okay, so a cylindrical shell, basically what we're going to do is we're going to rotate this graph that we've got, y equals square root of x and x equals 4. We're going to rotate this around the x-axis, okay? And so when we do that, though, we're not thinking of a circular piece. We're thinking now about a shell, which is a little bit different. So notice if we rotate around the x-axis, we have two from A to B. From in this case, A is going to equal 0, B is going to equal 4. Okay, so we're going to go from A to B. But the shell radius and the shell height now are going to be in terms of y. We're going to be in terms of y. Okay. And so, you know what? And there's the first mistake that you're going to make. Since everything's in terms of y, we have to look at what's going on in relation to the y-axis. So if we rotate around x, here's our A and here's our B. All right, so in this case, A is 0, B will be 2. And then we have to get our equations to say not y equals, but x equals, okay? So if I have y equals the square root of x, if I solve this for x, I'm going to square both sides. And that's going to get me y squared equals x, okay? So here we go. We're going to start setting up our integral. Our integral is going to go from 0 to 2 on the y-axis because we're rotating around x. It's a little bit different. And then we're going to have 2 pi in there. Well, because 2 pi is a constant, I can put it in the front. So I'll just move this guy over a little bit. I can put my 2 pi here. And then on the inside, I need to have my shell radius. And then I need to have my shell height. Okay, so these are two kind of different things. So remember, everything now is kind of in relation on the y-axis. So we're rotating around on the x-axis. Wow, that's really good. And so my shell radius now is actually going to be this part right here. All right, this guy right here is the shell radius. I'll use a different color. Here's my radius, and notice that my radius is changing every time. Okay, there's my radius, there's my radius, there's my radius. What is my radius? That's going to be y squared. Okay, whoopsie here. We're talking about radiuses, and remember, we're talking with the y-axis. So these r's are all correct, but what do those r's represent? They represent values of y. Okay, they represent values of y. And so the radius on this guy is how far in y coordinates we are off of the x-axis. Okay, so our shell radius is going to be y. Our shell height then is going to be where we stop, which is this 4 right here. We're stopping here at 4 on the x-axis, right? But we don't need any of, like if I went ahead and from this B, if I filled this in, we don't need any of this space right here. So our shell height, or how tall we are off of the y-axis, is going to be this way. This is our height, okay? And our height is going to be 4 minus whatever that function in terms of y is. So in this case, it's going to be 4 minus y squared. And always put parentheses, because if this was like y squared plus 2 or y squared minus 7 or y squared plus y plus whatever, then we want to subtract that whole function, okay? Which in this case, it's not too bad. It's just 4 minus y squared. So my shell height then is going to be 4 minus y squared. And then our change in our thickness of our shell is going to be the dy. Okay? So one thing that you can do that will help give you a good visual, because I'm a terrible 3D drawer, is you can look, go to Google and just type in calculus shell method. Okay, and it'll give you a much better kind of 3D-ish view with fancy software and all kinds of stuff. And you can just see a couple pictures to see exactly what the shell is. But it truly is giving us, instead of a washer, like a washer that you would build stuff with, it's giving us more of a shell, like a peanut butter jar, that we're using to determine the different ways to find volumes. Okay, so back to integrating this guy. It's not too difficult to finish it from here if you're one of my kids. Punch in your calculator. If not, remember we're actually going to integrate 4y minus y cubed, and so this would be 2 pi times 4y squared over 2 minus y to the 4th over 3. And we're going to evaluate that from 0 to 2. Now, the zeros, when we put zeros in, since we got zeros in all the terms, y's in all the terms, that will just cancel out and become 0. So we really just need to work with the 2. So that's going to be 2 times pi times 4 times 2 squared divided by 2 minus 2 to the 4th divided by 3. So 16 divided by 2 is 8. So we have 8 minus 16 thirds times 2 pi, which is going to be 24 thirds. So 24 minus 16 is 8. 24 minus 16 is 8 thirds times 2 pi, which is 16 pi over 3 units cubed. All right. Is that right? Let me make sure I did all my math right here. I feel like something's not right. 4 times 4 is 16 divided by 2 is 8. 2 to the 4th is 16 divided by 3. So 24 over 3 minus 16 over 3 is 8. Oh, there it is right there. There it is. I found it. This should be a 4. That makes some changes. There we go. There we go. My calculus senses were tingling. So let's fix that just real super quick. So this is going to be over 4. There we go. All right. So this is going to be 8 minus 2 times, let's see, 16 divided by 4, 8 minus 4, gee whiz. 8 minus 4 times 2 pi, that's going to be 4 times 2 pi, which is 8 pi units cubed. There we go, there we go. There's the shell method for you, and it's a little bit different, it takes some practice, but it's one that you can do. So depending on which way you rotate depends on the setup, okay?